In the electrical industry, the term range refers to a single unit consisting of both a cooktop and oven. Separate cooktops and built-in ovens are not considered a single range, and thus each appliance must be supplied by its own designated branch circuit. The National Electrical Code, or NEC, permits the use of taps where supplying power to multiple devices from a single branch circuit isn't feasible. These taps allow you to extend the branch circuit to serve additional devices, subject to certain distance limitations. These are covered in the NEC tap rules. Firstly, the tap conductors cannot extend more than 5 feet, or 1.52 meters, in any direction from the primary branch circuit conductors. Secondly, the tap conductors cannot extend more than 25 feet, or 7.62 meters, from the farthest device that the tap serves. Considering the specific scenario with a separate cooktop and built-in oven, they are treated as distinct appliances, each requiring its own branch circuit. In the described configuration, a number 8 circuit serves as the branch circuit for the cooktop and terminates at a junction box designated for the cooktop. A number 10 Romex tap can be extended from this cooktop junction box to a junction box dedicated to the built-in oven. However, this tap is permissible only if specific conditions are met. The distance from the number 8 branch circuit conductors located within the cooktop junction box to the point where the number 10 Romex tap originates at the built-in oven junction box must not exceed 5 feet. Additionally, the distance from the built-in oven junction box to the most distant point on the oven itself must not exceed 25 feet. Adhering to these limitations is vital to ensure compliance with the NEC and maintaining electrical safety within the installation. In other words, the cooktop and oven each get their own branch circuits. You can tap off the cooktop circuit to feed the oven if needed, but only if the distances meet those NEC requirements. Remember, the 5-foot rule applies to the distance between the main branch circuit conductors and the tap's origin. The 25-foot rule applies to the distance from the tap's endpoint to the farthest part of the device's powering. Let's delve into some additional considerations and best practices regarding tap rules in electrical installations. Proper sizing of conductors is crucial for safety and code compliance. When using taps, ensure that the tap conductors are appropriately sized to handle the load they will carry. Consult the NEC tables to determine the correct conductor size based on the ampacity requirements of the connected devices. Overcurrent protection is another essential aspect of tap applications. The tap conductors must be protected against overcurrent, typically using fuses or circuit breakers. The rating of the overcurrent protection device should be appropriate for the ampacity of the tap conductors and the connected load. Securing and supporting tap conductors properly is necessary for maintaining a safe and reliable electrical system. Use appropriate cable clamps, connectors, and supports to secure the tap conductors along their entire length. This prevents strain on the connections and reduces the risk of damage to the conductors. Careful planning and layout are essential for efficient and code-compliant tap installations. Before starting any wiring work, carefully plan the routing of the branch circuit and tap conductors. Consider factors such as accessibility, clearance requirements, and the location of junction boxes and equipment. Accurate measurements and calculations are critical for ensuring compliance with the tap rule distance limitations. Use a measuring tape or laser distance meter to accurately measure the distances between the branch circuit conductors, tap junction boxes, and connected devices. Double-check your measurements and calculations to avoid errors that could lead to code violations. Proper grounding and bonding are essential for electrical safety. Ensure that all metal enclosures, junction boxes, and equipment are properly grounded and bonded to provide a path for fault current to flow back to the source. This helps to minimize the risk of electric shock and equipment damage. When working with electrical systems, always follow safe work practices. To energize the circuit before starting any wiring work, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electricity, consult a qualified electrician. Regular inspection and maintenance are essential for ensuring the long-term safety and reliability of electrical installations. Periodically inspect the wiring, connections, and equipment for signs of damage, wear, or corrosion. Repair or replace any defective components promptly. Stay up to date on the latest electrical codes and standards. The NEC is updated every 3 years, so it is important to stay informed about any changes or revisions. This ensures that your electrical installations are always in compliance with the latest requirements. When in doubt, consult a qualified electrician. Electrical work can be dangerous, and it is always best to seek professional help if you are unsure about any aspect of the installation. An experienced electrician can ensure that the work is done safely and correctly, and that your electrical system meets all applicable codes and standards. To summarize, for a separate cooktop and built-in oven, they are not considered a single range. The number 8 branch circuit runs to a junction box for the cooktop. A number 10 Romex tap can run from the cooktop junction box to a junction box for the built-in oven, as long as the following conditions are met. Firstly, the distance from the number 8 branch circuit conductors to the tap junction box is not more than 5 feet. Secondly, the distance from the built-in oven junction box to the farthest point of the oven is not more than 25 feet. Now let's talk more about the tap rules for electrical circuits, particularly in the context of residential wiring. The National Electrical Code provides specific guidelines for how and where you can tap into an existing circuit to power additional devices or appliances. These rules are designed to ensure safety and prevent overloading, which could lead to fires or other hazards. The basic principle behind tap rules is to allow flexibility in wiring while maintaining safety. Taps are essentially short extensions of a branch circuit that are used to supply power to one or more devices. The NEC sets limits on the length of these taps, as well as the size of the conductors used to prevent voltage drop and ensure that the circuit can handle the additional load. One common application of tap rules is in kitchen wiring, where you might need to add an outlet for a new appliance. Instead of running a new circuit all the way back to the electrical panel, you can tap into an existing circuit that has sufficient capacity. However, it's crucial to follow the NEC guidelines to ensure that the tap is done safely and correctly. The first key requirement for tap rules is the length limitation. The NEC specifies that a tap cannot exceed a certain length, depending on the size of the conductors and the type of overcurrent protection used. There are typically 2 main types of tap rules: the 10-foot tap rule and the 25-foot tap rule. The 10-foot tap rule applies when the tap conductors are protected by an overcurrent device that is rated at not more than 10 amps. In this case, the tap cannot exceed 10 feet in length. The 25-foot tap rule applies when the tap conductors are protected by an overcurrent device that is rated at more than 10 amps. In this case, the tap cannot exceed 25 feet in length. In addition to the length limitation, the NEC also requires that the tap conductors be sized appropriately for the load they will carry. The ampacity of the tap conductors must be at least equal to the non-inductive loads served by the tap. This ensures that the conductors can safely carry the current without overheating. Another important consideration is the location of the tap. The NEC specifies that the tap must be made at a point where the branch circuit has sufficient capacity to handle the additional load. This means that you cannot tap into a circuit that is already heavily loaded. You need to ensure that the circuit has enough spare capacity to safely power the new device or appliance. When making a tap, it's crucial to use approved wiring methods and connectors. The NEC provides specific guidelines for how to make connections between conductors, and it's important to follow these guidelines to ensure a safe and reliable connection. Common wiring methods for taps include using wire nuts, crimp connectors, or terminal blocks. It's also important to properly support and protect the tap conductors. The NEC requires that conductors be supported at regular intervals to prevent strain on the connections. You should also protect the conductors from physical damage by using conduit, cable trays, or other protective measures. Before making any taps, it's a good idea to consult with a qualified electrician. An electrician can assess your existing electrical system and determine whether it's safe to add a tap. They can also help you choose the right wiring methods and connectors and ensure that the tap is done in accordance with the NEC. Let's consider a specific example of how tap rules might apply in a residential setting. Suppose you want to add a new outlet in your kitchen to power a microwave. The existing kitchen circuit is a 20 amp circuit, and it's already powering several other appliances such as a refrigerator and a toaster oven. Before you can add a tap for the microwave, you need to assess whether the circuit has enough spare capacity. You can do this by calculating the total load in the circuit, including the existing appliances and the new microwave. If the total load is less than 80% of the circuit's capacity, then it's generally safe to add a tap. However, if the total load is more than 80% of the circuit's capacity, then you should consider running a new circuit for the microwave instead. If you determine that it's safe to add a tap, you need to choose the right wiring methods and connectors. Since the microwave is a relatively high-powered appliance, you'll likely need to use a 12-gauge wire for the tap conductors. You'll also need to use an approved wiring method, such as running the conductors in conduit or cable trays. When making the tap, you should use wire nuts or crimp connectors to ensure a secure and reliable connection. You should also properly support and protect the tap conductors to prevent damage. Finally, you should test the tap to make sure it's working properly. You can do this by plugging the microwave into the new outlet and checking to see if it powers on. You should also check the voltage at the outlet to make sure it's within the acceptable range. In addition to the basic tap rules, there are also some special considerations that apply in certain situations. For example, the NEC has specific rules for tapping into feeder circuits, which are the circuits that supply power to the branch circuits. The tap rules for feeder circuits are generally more restrictive than the tap rules for branch circuits. This is because feeder circuits are responsible for supplying power to a larger number of devices, so it's important to ensure that they have sufficient capacity. The NEC also has specific rules for tapping into circuits that supply power to motors. Motors can draw a large amount of current when they start up, so it's important to size the tap conductors appropriately to handle the inrush current. In conclusion, tap rules are an important part of the National Electrical Code. They allow flexibility in wiring while maintaining safety. By following the NEC guidelines for tap rules, you can ensure that your electrical system is safe and reliable. The NEC is a comprehensive set of standards, and understanding it requires careful study and attention to detail. Therefore, it's always best to consult with a qualified electrician if you have any questions or concerns.